I'm excited to introduce Abby Bitterman. She'll be presenting Number or Words, How Perceptions of Probability Comprehension Influence the Communication Pathway for Weather Forecasting Products. Go ahead, Abby.
Yeah, thank you so much. And thank you for inviting me to come spend some time with you today to share this work with you all. As you'll notice in the title slide, it does say preliminary results. And so as I'll talk about a bit later, some of the results I'll be presenting today are actually from a survey we just completed fielding earlier this summer. So you guys are the first to see some of this new data. And so, yeah, with that, I will just kind of get going. So my name is Abby. I'm a research associate at the Institute for Public Policy Research and Analysis at OU. And I do most of my research in weather-related risk communication. And so again, I'm really excited to be presenting to you all today. And so with that, I'll kind of get started with the goals of this presentation. So the first is to map the communication pathway for weather information. And so we'll talk about that more a little bit later, but what we're really thinking about there is how do decisions forecasters make when they're communicating weather forecasting information impact the public's ability to understand that information and correctly interpret it, and then take it forward and use it in their own decision making. We also want to better understand how forecasters prefer to communicate probabilities. We want to analyze the ways in which different types of probabilistic expressions impact public understanding, perceived risk, and intended response to probabilistic weather service products. And then finally, we're also going to be exploring the challenges forecasters face when trying to communicate probabilistically. So to begin with a little background, most forecasters use words and phrases to communicate probabilistic information, but the public prefers to see both words and numbers, and believes forecasts are more reliable when numeric probabilities are shown. So seeing those numbers really helps with a bit of an increase in trust in the forecast. And when I say words, obviously every message is going to have words, but if I ever just say words, I am meaning words of estimate of probability. So possible, chance, low likelihood, things like that. And the public also has a wide range of interpretations for the words forecasters use to convey probability. So on a scale of 1 to 100, what the public views chance as meaning can differ pretty significantly. But most tweets coming out of the Weather Service are only using words of estimate of probability as opposed to numbers to convey this probabilistic information. So even though there is a wide interpretation for these WEPs. And finally, on the whole, research is pretty clear that we ought to be using numeric information when trying to convey the probability of an event. But as we've just talked about in that Lenhart et al. Study from 2020, that isn't very oftentimes what's happening. So this research is really going to dive into why that might be. It doesn't necessarily have all the answers, but maybe just some initial thoughts about why it might be that this numeric information is important, but it's not always being used. So to do this, we use data from 2 different surveys. The first one that we'll focus on is a survey of forecasters that was done in 2020. And the second was a survey of the public that was fielded just this summer in 2023. Like I said, this is the first time that data from that survey is being presented, so that's pretty exciting. You may notice that there's quite a big time gap between these two, and that's because this has been a very iterative process. So we have actually done some other studies. You may have seen this presentation as part of this past year's AMS with some different data from, excuse me, a different public survey. And This, like I said, this has been a very iterative process. And so we've kind of changed the ways over time that we look at the different ways that we look at the different types of probabilistic expressions. So this analysis is going to be much more expansive of the types of the ways we classify different types of probabilistic expressions. And then also on the side here, you'll notice the two main graphics that we'll be focusing on. I know this is the central region, and you guys might not use the tropical related products very much, but I do think they are a little bit topical with a hurricane on its way to Florida right now. And also, I think at the end, we'll see that there are some lessons from this overall that can be applied regardless of the type of weather event that it is. But so the two graphics we'll be focusing on throughout the presentation are first the wind speed probability graphic, and we'll be focusing in specifically on this location here, location A. The white circle was not part of the graphic when it was shown in the surveys. I'm just adding that here to point it out. And then the second one is the potential storm surge flooding map. A little bit more difficult of a product, but still an important one to use. And this one actually has an exceedance probability, so it gives us a little bit of a different look. But again, and we'll be focusing on location A here. So the first thing that I want to talk about is this communication pathway that I mentioned a little bit ago. So we're kind of going to be going through this pathway essentially in order, and we're going to be starting with how forecasters perceive the public's ability to understand and interpret and use probabilistic information. We're then going to look at how that impacts the types of communications they write, and then how these communications impact comprehension on the part of members of the public, and finally, how that impacts the response to these messages that members of the public have. I also want to say that we recognize that emergency managers and other partners are very important parts of communicating forecast information to the public. But for the sake of this presentation today, we're not really going to focus on their role, but just want to acknowledge that they do play an important role in the communication pathway. So now we're going to start to look at some of that survey data. So first, we want to look at how forecasters perceive the public's ability to understand probability. Throughout the course of this presentation, you'll hear me talk a lot about numeracy. Numeracy is very similar to literacy. It's just for numbers. Generally, it's how people are able to understand and use probabilities in numbers. Forecasters, like yourselves overall, have high levels of numeracy, especially compared to the average member of the public, probably from all those math classes you have to take to get a meteorology degree. And forecasters also view the public as having very low numeracy. On that survey of forecasters that I talked about, the forecasters were asked, how do you rate the ability of average people in your area to calculate and interpret probabilities when making decisions? And about 90% of the forecasters rated the average person in their area as being fair or poor at using probabilities. Of note, none of the forecasters rated the average person in their area as excellent. So overall, the perception of the public's ability to use probabilities is generally pretty low. And in reality, they're correct. So this graph, or this plot, shows a distribution from that survey of members of the public on a general numeracy score that we gave them. They got this score because they were asked a series of probability questions, starting with, if you flipped a fair coin 500 times, how many times would it land on heads? And getting increasingly difficult from there. And so we see that the average score for that was pretty low. But when we ask them these same questions, but in the weather context, numeracy gets a little bit higher. So people are a bit more able to, on average, use probabilities in the weather context more so than they are in general. But I think it's also really important to note here that while there's we've been talking about the means, there are people at both ends of the spectrum, especially in the weather numeracy plot here. And so when we're talking about communicating to members of the public, we can't just think about these mean people here. We have to think about the people on both ends of the spectrum. And so when we get to the public comprehension of these products and these messages a little bit later on, I think this is a really important graph to keep in mind. So, but numeracy isn't the only thing that is important when it comes to a person's ability to understand and use and interpret weather service products. Another thing is the message that comes along with those products. So in that survey of forecasters, we showed them these two graphics one at a time and asked them the same question both times. We asked them, how would you explain this information in a short message to average people in location A? For simplicity, please limit the explanation to 280 characters, kind of thinking like it's a tweet. And so we then coded these messages that the forecasters wrote according to a coding scheme developed in Lenhart et al. That we've expanded on a little bit. We asked ourselves a series of questions. We first asked, is this message a forecast? Does this message have probabilistic information? Because we were specifically interested in probabilistic forecasts. Is the probabilistic statement using numbers, words of estimate of probability, or both? Are the words in the probabilistic statement qualified, unqualified, or both? And we'll talk a bit more about what that means in a second. And then finally, does the message include the correct interpretation of the probability? Now, as you may have noticed in when we discussed the background information, a kind of similar study from Lenhart et al. Has been done looking at forecaster tweets to the public already. We kind of wanted to test it in a more idealistic survey setting to see what forecasters would write when they didn't have to be worried about people seeing it or things like that. And so that's, I just want to throw in as another kind of motivating thought behind this experiment. And so here is just, this is a very intense chart when you first look at it, but it's kind of just the progression of that coding scheme I just laid out. And so how we asked this set of questions and moved through it. And we'll see this chart again when we break down the messages. And before we start to look at those messages, I just wanted to make a quick note about what is a qualified versus unqualified word of estimate of probability. Quite simply, qualified WEPs include a qualifier like slight, some, very low. Examples would be low chance or highly likely, whereas unqualified are just words like chance, possible, it's probable. They don't really have a word that lets you know like what kind of chance it is or how possible it is. So that's what we mean for the rest of the presentation when we're talking about qualified versus unqualified words of estimate of probability. So now finally, we're going to start looking at some of these messages that forecasters wrote. First, for the wind speed probabilities, an example of a numeric probabilistic expression that one forecaster wrote was, there is a high chance, or 80 to 90%, that hurricanes force winds will be experienced in your location. This one we would actually code as both because they use a qualified word of estimate of probability and the percentage and the numeric probability. A qualified WEP statement would look like, you are extremely likely to experience hurricane force winds. And then finally, an unqualified WEP statement would be, residents at location A should expect hurricane force winds. And again, I will say that 80 to 90% chance, or 80 to 90% is the probability for location A. I know it can maybe be hard to see because the photo is a little bit small in what I put in this presentation, but they are, location A correctly is in the 80 to 90% range. And so then when we break that down into the types of messages that the forecasters wrote, 202 of the 209 total messages did include a forecast. So we eliminated those 7 that didn't. Of those, 188 were probabilistic. I think because the probability was so high, there was maybe a thought to go deterministic, but we eliminated those deterministic messages. And then of those, the overwhelming majority included just probabilistic expressions made with words instead of using the numeric probability. Here we look at, when we classify them as qualified or unqualified, we include the both category, since like we saw in that last slide, some of those numeric statements also included words of estimate of probability. And here we find that the forecasters were writing pretty evenly qualified and unqualified messages. This may be because it was a very high likelihood event. And so since the probability is high, it's very easy to qualify that as a high chance event. And then finally, we take all three of these types of messages, and we find that almost every forecaster interpreted this product correctly. It's a very straightforward product. It's been around for quite a while, and so it's probably pretty well known. And again, it's a very high probability, so it was a little bit easier to interpret. For the storm surge graphic, an example of a numeric probability would be there is a 10% chance of storm surge exceeding 9 feet, which is the correct probability, I will say. The red area is greater than 9 feet above storm surge. And if you read the little tiny text down here, it says that it's a 10% chance of exceedance. An example of a yep, this is the qualified one, of a qualified WEP statement would be location A has the highest risk for seeing significant flooding. And an example of an unqualified statement would be you will possibly have a surge of 9 feet or more. And so for this one, 201 of those 209 messages were forecasts. 193 of them were probabilistic. Overwhelmingly, again, the forecasters used words of estimate of probability rather than numeric probabilities in those messages that they constructed. And overwhelmingly for this one, the probabilities were unqualified, or the words were unqualified. This may be because it's a low probability, high impact event. I don't really want to speculate too much about why there were more unqualified messages in this one. But if I were to take a guess, I would say it was probably because it's a 10% chance, but of seeing something really bad happening. And so there might be more hesitation to qualify what kind of event this would be. And in this one, the forecasters actually had several more incorrect interpretations of the probability. This may be because, like I said, when I was pointing out, the text is very small at the bottom. It's a bit of a, in the scheme of things, a newer probability. And again, it's just overall a little bit less straightforward. But so even with the forecasters themselves, we saw a bit more, a few more incorrect interpretations with this graphic. And so then we wanted to know how those perceptions of numeracy that we talked about earlier on influenced the types of messages that we saw the forecasters writing. So starting with the wind speed graphic, we broke down public numeracy into 3 categories, or rather the forecaster's assessment of public numeracy into 3 categories, with this green being low, blue being moderate, and red being high. You'll notice the big error bars on the high group, and that's because, as we saw in that previous in the earlier slide near the beginning, not many of the forecasters have a high assessment of public numeracy to begin with. But so looking first at the types of probabilistic expression broken down into numeric, words of estimate of probability, and both, we see that forecasters who view public numeracy as being high were a bit more likely to write numeric statements of probability, but overall, most of the forecasters wrote statements using words of estimate of probability, like we saw in the flow chart. Similarly, when we look at the storm surge graphic, we see the same story. Forecasters who view public numeracy as being high were a bit more likely to write numeric expressions, but overall, most of them were words of estimative probability. And then when we look at the types of words of estimative probability, definitely forecasters who view public numeracy as being high were definitely more likely to write qualified statements. But the same isn't true when we look at the storm surge graphic. And so overall, there's really not a lot of statistical significance across these last couple of graphs that I've shown you. The goal of these plots was to start to get at why forecasters were using either numeric expressions or qualified or unqualified words of estimative probability. And so one thought we had was that it might be based on their assessment of public numeracy. And what we find here is that may be a bit true, but there might be something else going on. And so we're going to dive back into this question later. But I think the big takeaway here is that forecaster perceptions of public numeracy are definitely part of the story, but they don't tell the whole story. But for now, we're going to move on to how members of the public interpreted these messages that the forecasters wrote. And like I said at the top, this is preliminary analysis of new survey data. So we're still sorting through the findings, making sense of it all, but wanted to share some new survey data with you all here today. So in this survey, an experiment that we did was we showed the members of the public, we broke them up into 4 groups. They were all asked the same question: which of the following statements best describes the probability of hurricane force winds in location A? And they saw one of 4 treatments. So the first treatment before answering the question, or that they saw along with the question, was just the map with no message. So this is going to be our none group, because they saw no message. The subsequent groups saw the map with a message right here, like where a tweet would be. So one group saw an unqualified WEP message that said expect hurricane force winds to hit. Another group saw a qualified WEP message that said there is a high chance that hurricane force winds will hit. And finally, the 4th group saw a numeric probability message that said there's an 80 to 90% chance that hurricane force winds will hit. I will say that these messages are not exactly what the forecasters wrote. We have done, like I mentioned before, previous surveys that tested pretty much a very similar concept using exact quotes from the survey of forecasters. But for this survey, we wanted to really get at just the message of just the probabilistic expression itself. And because of that, we wanted to make all of the messages equal besides the probabilistic expression. So you'll notice that the second half of all of the messages are the same. That wasn't necessarily the case in all the messages that the forecasters were writing. So to really be able to get at the thing that we're testing, we just wanted to kind of equal everything out. But we were heavily inspired in the messages that we wrote by those forecaster messages that we looked at from the previous survey. Same thing for the storm surge. There were 4 groups again. They saw the map, or one group saw the map, and then the other group saw the map plus one of them saw the unqualified WEP message that said possible storm surge of greater than 9 feet. Another group saw a qualified message that said there is a small chance of storm surge of 9 feet or more. And then finally, the 4th group saw a numeric probability message that says there's a 10% chance that storm surge will exceed 9 feet. And so now we're going to look at how these different messages impacted the public's ability to understand, to correctly interpret the graphic. And so we find that for the wind speed probability graphic, the numeric probability, the group that saw the numeric probabilities more often correctly interpreted the graphic than not. I will say that in underneath that question that we just looked at, there were 4 response options. 1 was the correct interpretation, and then there were 3 that were incorrect. So these were all the people who selected the correct interpretation. It is worth noting that for the none group that saw just the map and the 2 groups that saw the word of estimate of probability statements, even though it looks like the unqualified is higher, these error bars pretty well overlap each other for the most part. So this is not really a statistically significant difference between these groups. So for all intents and purposes, we can say that these are almost essentially the same, and the numeric treatment group is really having the most effect on public comprehension of the wind speed probability graphic. And the same is even more true for the potential storm surge flooding map. So again, the none, the unqualified words of estimate of probability, and the qualified all down here kind of together. And then those who saw the numeric probability message got the question correctly interpreted the graphic significantly more often. And so we wanted to make sure that these results held regardless of public ability to of public numeracy. So we looked at both ends of the spectrum, like I talked about on that plot near the beginning of public numeracy, and we broke them down based on general numeracy into 2 groups, low numeracy and high numeracy. There is a moderate category, but we're not showing it here because we wanted to really just focus on the 2 ends of the spectrum. And so we can see that for the highly numeric group, this blue line, for the wind speed probability graphic, the numeric expression really did help that group. And also, even on the low end, the comprehension and correct interpretation of the graphic was more likely, happened more often for those with low numeracy when they saw the numeric expression. The same is also true for the potential for storm surge flooding map, which again, we kind of talked about at the beginning is a bit less straightforward of a graphic. And so we can see that for those who have high numeracy already, they were, the group that just saw the map was able to interpret it, and the words of estimate of probability actually hurt their interpretation, while the numeric probability did help them. And same for the low numeracy group. So regardless of a person's level of numeracy, the numeric probability statements were able to help them correctly interpret the graphic more often than the statements that included words of estimate of probability. So regardless of group, numeric probabilities were really important. We also wanted to look at perceived risk versus intended response. And so for the wind speed probability graphic, it's no surprise, like we said, it's a very high probability. So it's it makes a lot of sense that regardless, intended or risk and response were both rated very high across all groups. For the storm surge, we see a very different story where those who saw a qualified word of estimate of probability statement or numeric statement had lower risk and response perceptions than those who saw no message or an unqualified statement. And so this brings up a really important point that words of estimate of probability aren't the, or sorry, that numeric probabilities aren't the only answer, especially for this storm surge, which was a 10% chance of 9 feet or more of storm surge occurring. So we would really consider that a low probability of a high impact event. And so this is the type of event that we may see that the numeric probabilities are still important to show, but they need a bit more context. It needs to be explained potentially what 9 feet of storm surge looks like, why it's something to still be very concerned about. And the numeric probability just needs a bit more context around it. So throughout all this, we can see that numbers really matter. This research confirms what previous research has shown, that numeric information is helpful for public interpretation, even for people with low levels of numeracy. But it also reiterates that most forecasters are still using just words. And like we saw in the kind of first half of this with the forecaster survey, we don't really have a good answer for that yet. So we're still left with this question of why. So for that, we look at an open-ended question at the end of the forecaster survey that asked forecasters if they had any specific experiences, ideas, or concerns that might help us understand the challenges they face when trying to interpret or communicate probabilistic forecast information. So we took all those responses. There were some really great thoughts in there, and then we coded them based on the overall message of the comment, and about 49%, basically half of the responses, discussed the need for better communication tools, and 26% included the need for products that are more easily interpreted. And so that's something that forecasters are really concerned about when they're communicating probabilistically with the public. Forecasters also expressed concerns about perceptions of the public's inability to interpret probabilities. About a quarter of respondents directly expressed a negative opinion of including probabilities in messages to the public. But other forecasters saw the benefits and specifically pointed at the public's desire to see numbers, which we see reflected in research as well. Only 11% of respondents, though, expressed a positive opinion of including probabilities in messages. Some of the messages we saw included one that said, "We just don't have the resources to educate everyone in the public on probabilistic forecast information. I think it's worthwhile to educate our core partners and use such information in our briefings to them, though." Another said, "In a nutshell, the public prefers probabilities, but they don't understand them, which results in a drop in credibility in their eyes." And finally, another forecaster said, "I don't believe the public understands probability, but for some reason they like to see a number. I assume they associate that number with something. I would prefer to send out just the wording I mentioned above, but they likely don't understand that either." And so I hope in what you've seen in the presentation to this point would kind of begin to push back against some of this. There is an overwhelmingly negative perception about the public among forecasters that may be what's leading to these statements being more heavily words of estimate of probability as opposed to numeric probabilities. This still requires more investigation, but I think that some of these attitudes are definitely something to be watching out for. There were some forecasters who spoke positively about the public, though, and so I wanted to make sure to include them. One forecaster said, "Using words versus numbers, people have their own interpretation of the words, like slight, marginal, moderate," which I will add as an aside, we did see in that previous research that I talked about. As a WCM and forecaster, when I worked more out with people, this caused confusion at times. Another said, "Our words are confusing to people I encounter. A number from 1 to 100 is much easier to understand if done in the right manner." And then finally, one forecaster said, "I think that we must accept that people interpret forecast information differently. As such, numbers work great for some, especially percentages, while others may prefer words, high confidence, slight chance. Messaging needs to be flexible." And so because of this, and since about half the forecasters in that survey said that they felt they needed more tools, we wanted to end this presentation by offering some quick guidance for using probabilities. So a couple of good practices include using numeric probabilities to support verbal phrases of uncertainty. So if you're saying, so for example, adding on, say, "Storms are likely today," and then say there is a 70% chance of seeing storms. So you're including both kinds of messaging. Don't be afraid to repeat information and put the information from the legend into the text. We saw that a lot in the products we looked at in this presentation today, that essentially what the numeric messages were doing were just repeating the legend, and that helped people. Explicitly state the reference class. So if, like, for example, with probabilities from the SPC, saying that those are the probability within 25 miles of a point. Give context, especially for low probability, high impact events, like perhaps seeing the possibility of seeing 9 feet or more of storm surge only occurs 2 times a year, or maybe even less. Give that context so people know what a big deal this is, even if it's a low probability. And for more recommendations like this, these all come directly from Ripperger et al. 2022, another study or literature review actually put together by IPRA that I would really encourage you to check out if you haven't already. And then when it might be good to use numeric probabilities when sharing products that include probabilities like those that were tested in this study in advance of an event, which we'll look at a bit more in just a second. When writing a chance of statement. So again, like we mentioned in that last slide, thinking of numeric probabilities almost in like an improv sense as a yes and. It doesn't have to be words of estimate of probability or numeric probabilities. Putting them both in together can be really helpful for people across both ends of the numeracy spectrum and just to make messaging more flexible for all types of people. And then finally, when there's uncertainty in the forecast, it's great to make sure the public is aware of that uncertainty. And so now I know we've talked a lot about tropical products today. And again, I think that these results are similar or can speak beyond the type of product they are. But I wanted to talk more about the types of weather that you might experience in the central region. So this is a graphic that comes from a paper by my colleague, Mackenzie Krochak, who's also on this call today, from a study that looked at what types of information members of the public are looking for at different times in advance of a weather event. And so first looking at severe weather, people are really looking for chance or probabilistic information. Further out from the event, like for severe weather, 3 days before the event. And as we get closer to the event, you might not want to prioritize using probabilistic information anymore, even though it exists, because as we get closer to the event, members of the public are looking for different kinds of information like protective action, location, and severity. So while this presentation is really focused on the importance of probability, at all times in advance of an event, it's not necessarily the most important information to share with people. Exact same story in winter weather, 5 days and 3 days out from a winter weather event hitting. That probabilistic information, chance information is more important. And as we get closer, severity, protective actions and impacts become more important to people. And once again, we see that chance information falls all the way off to the bottom. This is another really good paper that I would highly recommend if you haven't read it already, to learn more about what members of the public are looking for in time in advance of an event. And so finally, just to sum it all up, forecaster perceptions influence the message characteristics of what they're writing to the public, and the forecaster perceptions of public numeracy are generally negative. Message characteristics subsequently impact public comprehension and interpretation, and the public prefers to see numbers in addition to words. Those numeric probabilities, as we saw, really helped people. The probabilities don't tell the whole story, though, and context is important, especially in when it's a low probability, high impact event like that storm surge graphic that we looked at. And then finally, there are no silver bullets in risk communication. This whole presentation has been centered on probabilities and using numeric probabilities, but probability is one tool. It's not the only tool. And there may be certain times, like we just looked at, when it's better to use probabilities, or times when it's better to prioritize other information. And so with that, thank you so much for your time. I know if you were on the call earlier, I said it was going to be about 30 minutes and it went about 40. But I really appreciate you all coming to this talk and inviting me to speak with you today. And with that, I'll take any questions you might have. But again, thank you so much for your time.
Yeah, we also like to thank you, Abby. That was an excellent talk. So if anyone has any questions, please raise their hand or put it into the chat. Go ahead, Phil.
Yeah, great talk, Abby. I think one thing that at least I struggle with and other forecasters is that talking about probabilities in a message for a point is easier because it's one probability for one point than when it varies over a larger area. And then you get into the question of what probability should you be using numerically? Should you be using the whole range over that entire area? Should you highlight the highest probability? I guess I'm kind of curious what your thoughts are on that.
Yeah, I think that is a really important point and something that's definitely worth further study. I don't think I have a complete answer to that. I do have a couple of thoughts. One might be that you could potentially like highlight maybe your biggest population center and say, like if you were showing a map or something like the graphics we looked at today, and say, this is the probability I live in Oklahoma, for example. So the Norman WFO might say, this is the probability in Oklahoma City. Use the legend at the bottom, and this is what it means. Use the legend in the bottom left of the map to find your own probability of XYZ event. That's just one idea. Or it might be worth listing a couple of different ones, or maybe like you mentioned, pointing out the highest probability and saying, or the area in the highest probability zone and saying, but that's not the only area that has the chance to see this event today, and directing them to that legend, making sure they know it exists. Again, those are just a couple of ideas, but I think it's definitely something worth IPRA exploring more, because like you pointed out, this work is really focused on talking to people about one point. And it definitely would be a great area for future study to look across, to look at communicating across a range of areas. Kenzie, do you have any additional thoughts on that?
No, Abby, I think you covered it really well. I agree with how Abby said, especially, depending on the event, I think it's situationally dependent. And so if it's beneficial to highlight the highest probability, especially, if it's maybe there's a probability of winter precipitation in the southeastern corner of the CWA, for example, obviously highlighting that area and highlighting the fact that there is a very low probability or no probabilities for the other area is useful. But I also thought that Abby's suggestion focusing on, here's a probability in this town, this town, this town, and this town, see the map for other locations, is a great example of helping people interpret the probabilities in front of them. And then if they want more specifics, they can hopefully go to the graphic. I know that usually what usually happens then is people then say, what about my town? What about my town? And so there may not be a great way to get away from that, but just giving that extra context and, repeating what's in the legend, or showing people how to interpret this graphic with a couple examples is really, really helpful and reassuring for people. So I liked that suggestion a lot, Abby.
Yeah,
great
thanks.
question.
And, yeah, really great question. And also, as Kenzie pointed out, like there might be people who say, well, what about my town? But that I think is at least getting them to interact and look at the map a bit more. And also for every person that is asking that question, there might be another person who found their town on their own. So giving them some context that might make them a bit more self-sufficient in the future. But I don't know that for certain. That's just one idea that I had spurred by Kenzie's comment. But thank you so much for that question, Phil.